Now, we know that the background of this international short course is quite various and we have a great team as well. For the lecture 6 will be delivered by Associate Professor Dr. Kamaruddin bin Ahmad from University of Malaysia. And then will be the moderator of Mr. Abdul Rahim. Is it Mr. Kamaruddin our us? Yeah. For Mr. Kamaruddin and then the moderator Mr. Abdul Rahim, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. We hope that you are still happy to join us till this Friday. Right now, our speaker has joined with us. First, let me greet Pak Kamaruddin. Assalamualaikum, Pak Kamaruddin.
Waalaikumsalam warahmatullah. Pak Abdul, can you hear me?
Yeah, thank you. Thank you for joining us, Pak Kamaruddin.
Okay, can you hear me clearly?
Yes, sure.
Okay,
Pak.
okay,
Yeah.
that's good. Okay, that's good.
Okay. This afternoon session, we'll talk about the soil liner. We know that in the surface of land, we see a lot of garbage that potentially contaminate the water. So, Pak Kamaruddin will tell us a lot about how to make a soil liner in order to minimize water that come from garbage, not to contaminate the water, because the water that we use for drink, for the another effective another thing, yeah. So Pak Kamaruddin has interesting, I think it's very interesting topic for us to, we can learn a lot about the material. Yeah. Okay, but first, let me introduce Pak Kamaruddin. Pak Kamaruddin is the faculty member of civil engineering in University Technology Malaysia. Pak Kamaruddin completed his academic level from from bachelor program, master program, and doctoral program, all in civil engineering. Yeah. Pak Kamaruddin has a lot of experience in something related to soil, because Pak Kamaruddin has a concentration in geotechnical engineering and also transportation. So the main qualification of Pak Kamaruddin is all about something related to soil in the underground and also in the surface used by transportation. Yeah. So I think it's enough for the introduction. So please, Pak Kamaruddin, to start the presentation. I give you around 45 to 50 minutes, Pak Kamaruddin. Time is yours. Thank you.
Okay, thank you very much, Pak Abdul, for the introduction. Okay, before that, let me introduce myself. Right? How to share. Uh, can everybody see my slide?
Not yet.
Not yet.
Yeah.
No, no, it's not visible.
Okay, I'll try. Uh, not yet. What's the problem here? Okay, let me see. Share screen. Share. Okay, can you see my slide?
Yes, Pak.
Yes, we can see.
Yeah.
Okay, right. Okay, my name is Kamarudin Ahmad. I am from the Department of Geotechnics and Transportation, Faculty of Civil Engineering, University Technology Malaysia in Johor Bahru. Okay. Uh, to begin with, I would like to congratulate the organizing committee of this RMI Week 2023 for their efforts to successfully organize this event. In addition to that, I would like to express my sincere gratitude to the committee for giving me the opportunity to participate in this afternoon session. Okay. So with this allocated time, about less than 1 hour, okay, I'll be talking about matters related to environmental geotechnics, specifically about compacted soil liner for landfill facilities. So before I start talking about this compacted soil liner landfill facilities or about landfill facilities, allow me to show you a 10-minute video on landfill facility, which I obtained from KUB Berjaya Sendirian Berhad, the developer and the operator of Bukit Taga landfill. This Bukit Taga landfill is situated in about 50 kilometers from Kuala Lumpur to cater for solid waste generated from Kuala Lumpur and the surrounding area in Selangor. So let's watch this video, about 10 minutes video, to give you some idea what landfill is all about. Disposal. The challenge is to develop socio-economic context. The Bukit Taga Cemetery landfill sets the
Kamarudin, sorry for interrupting you. Voice of the speaker is very small.
listed on the Malaysia Stock Exchange. Taga Cemetery landfill is supervised by the Ministry of Housing and Local Development.
Pak Kamarudin, sorry to interrupt you. Your
Yeah.
video, we don't hear the voice. So please make it louder, Pak.
To Malaysia Highway Authority and JTR standards.
Make it louder, Pak.
Can you hear the sound?
No, still.
No, sounds off.
Yeah.
Is great.
Okay. Is
I already gave the maximum volume.
okay.
Uh-huh. Maybe you have to increase the volume of your computer. Or maybe I try to increase the volume again. Okay, stop sharing. I try to share again. Maximum volume. Okay, and then
Sir, I think there is an option when you are sharing, share with audio.
with audio. Let me check. Sharing. Can you see the slide? No? No, can you hear that?
Here, but the slide not show.
Saga Cemetery landfill commenced operations on April 1st, 2005. Apart from
Pak
We see
Kamarudin,
only your face. I'm
Pak
sorry,
Kamarudin,
but no
I
video.
have already your file. Maybe we
Audio
can
is here, but
we can
the
help
slide is not sharing.
help to play from Unisula, Pak. Just let me try.
maintaining the integrity of the environment.
Wait a minute.
Yeah, please. Increase the volume. Increase the volume. Increase volume. And then share screen. Share. Can you hear the volume?
The Bukit Taga Cemetery landfill is designed
Better than previous.
as our lifestyle becomes more fluid. Each generation has also increased.
Can you hear the voice?
It's the predominant method of waste disposal in Malaysia. The challenge is
The sound
Yes,
still
sir.
lower.
We can.
Okay, good.
environmentally friendly waste management facilities. In this context, the Bukit Taga Cemetery landfill sets the benchmark, being the premier cemetery landfill in Malaysia and in the region. The Bukit Taga Cemetery landfill is developed by KDB Berjaya Enviro City Berhad, a joint venture company established between KDB Malaysia Berhad and Berjaya Corporation Berhad, two conglomerates listed on the Malaysia Stock Exchange. Based on an agreement with the government of Malaysia, Bukit Taga Cemetery landfill is supervised by the Ministry of Housing and Local Government. Located 50 kilometers from Kuala Lumpur, the Bukit Taga Cemetery landfill is accessible from the North-South Expressway via a purpose-built interchange and 9-kilometer dual two-lanes carriageway access road with full street lighting to Malaysia Highway Authority and JTR standards. The Bukit Taga Cemetery landfill has ideal As our lifestyle becomes more affluent, waste generation has also increased. Far from established townships and housing
We play
developments,
from Unisula, Pak Kamarudin.
are at least 500 meters away from the landfill. Landfill is the predominant method of waste disposal in Malaysia. The challenge is to develop socio-economically viable and environmentally capacity of 120 million metric tons is capable of handling waste.
Pak Kamarudin,
Yeah.
please stop your slide. We play from Unisula. It's better for the sound. The sound. Just stop your slide.
From employing new technology, Bukit Taga Sanitary Landfill gives utmost priority in maintaining the integrity of the environment. Management facilities.
Just stop, Pak.
In this context, the Bukit Taga Sanitary Landfill sets the benchmark, being the premier sanitary landfill in Malaysia and in the region.
What is double?
The Bukit Taga Sanitary
Yeah.
Landfill is developed by KUB Berjaya Enviro Sdn Berhad, a joint venture company established between KUB Malaysia Berhad and Berjaya Corporation Berhad, two conglomerates listed on the Malaysia Stock Exchange. Premised on an agreement with the Government of Malaysia, Bukit Taga Sanitary Landfill is supervised by the Ministry of Housing and Local Government. Located 50 kilometers
slide is
from
this?
Kuala Lumpur, the Bukit Taga Sanitary Landfill is accessible from the North-South Expressway via a purpose-built interchange and the new 9-kilometer dual 2-lanes carriageway access road with full street lighting, built to Malaysia Highway Authority and JTR standards. The Bukit Taga Sanitary Landfill has ideal characteristics. One key feature is its location away from an urban environment. The site is in the middle of an oil palm estate, far from established townships and housing developments. A large buffer zone ensures developments are at least 500 meters away from the landfill. Bukit Taga Sanitary Landfill is the first landfill in Malaysia to provide a full-fledged buffer zone. Bukit Taga's approximate capacity of 120 million metric tons is capable of handling waste generated in Kuala Lumpur and Selangor for at least 40 years. The Bukit Taga Sanitary Landfill commenced operations on April 1st, 2005. Apart from employing modern technology, Bukit Taga Sanitary Landfill gives utmost priority in maintaining the integrity of the environment. The landfill conforms to the requirements of the Department of Environment, particularly the conditions of the approved detailed environmental impact assessment report. The Bukit Taga Sanitary Landfill is designed as a Level 4 sanitary landfill based on US EPA standards. Level 4 is the highest standard achievable and ensures maximum protection to the environment. The base of the landfill faces are compartmentalized into various cells to achieve optimum storm water control to minimize leachate production. The cells are progressively filled until they reach full capacity. The landfill cells have a multi-layer base liner to prevent any leachate from infiltrating into the ground. An integrated leachate collection system collects leachate from the liner into a chamber to be conveyed to the leachate treatment plant. A canvas sheet covers exposed surfaces of the base liner membrane to prevent rainwater infiltration into the leachate collection system. Selected trees like neem and eucalyptus are planted around the site to promote a greener and pleasant environment. To maintain integrity of the environment and reflect its standing as a world-class sanitary landfill, Bukit Taga employs a comprehensive landfill gas management strategy. This involves treating landfill gas by way of flaring in the initial stage and subsequently generating electricity from the landfill gas as a sustainable source of energy, with a prospect of supplying power to the national grid. Bukit Taga Sanitary Landfill is also participating in the Clean Development Mechanism under the Kyoto Protocol. The Clean Development Mechanism is an arrangement supervised by the United Nations, where projects in both developed and developing countries commit to reducing greenhouse gas emissions. The Bukit Taga Sanitary Landfill is managed by a team of highly trained professionals. Daily operations are organized and executed efficiently for optimum results. A smart card system improves traffic efficiency and ensures accuracy in reporting the loads of all trucks. Waste is disposed at designated tipping platforms. Specialized compactors compact the waste for maximum airspace capacity. Earth is transported daily from the stockpile to be applied on the compacted waste to reduce odor and maintain hygiene. The earth cover is subsequently compacted to prevent infiltration of storm water into the cell. Once the cell reaches full capacity, a green high-density polyethylene liner is applied over the final compacted earth layer to optimize methane gas extraction and to completely shield the cell from rainwater. Any excess leachate in the truck is discharged at the leachate chamber before the truck is cleaned at the wash trough. The water bowser cleans the road to prevent dust pollution. The leachate management and treatment system at Bukit Taga Sanitary Landfill is the most advanced in the region. A world-class fully automated facility, the leachate treatment plant operates via the SCADA computer system. Leachate is collected through a collection system to prevent infiltration into the ground. To avoid storm water from mixing with leachate, an extensive stormwater drainage system diverts stormwater from the cell to the stormwater detention pond. Leachate is conveyed to fully lined holding ponds before it's transferred to the leachate treatment plant for treatment. At the treatment plant, leachate is dispensed into 4 sequential batch reactor lagoons at regular intervals, where it's biologically treated for 24 hours before being placed in the dissolved air flotation tank to expel all residual suspended solids and colloidal particles. The filter press system ensures maximum dewatering is achieved before the dry sludge is subsequently discharged at the landfill. Treated leachate is directed to the reed beds for final polishing. The fragmentous plants absorb residue in the treated leachate to further improve its quality. Bukit Taga Sanitary Landfill is the first and only landfill in the region to employ this process. At this stage, the treated leachate has achieved standards allowing discharge into open water courses. However, Bukit Taga Sanitary Landfill employs a zero discharge policy. Instead of discharging treated leachate into open water courses, it is irrigated into a large field by an extensive sprinkling system. This offers optimum protection to the environment. Daily tests are carried out on the treated effluent to ensure highest standards are achieved. Regular maintenance results in optimum performance at all times. The landfill is equipped with an emergency response system and leachate containment bund to prevent accidental leachate breakout from escaping into open water courses. A continuous river flow monitoring system is also installed at the main water course. This helps prevent effluent from entering the river system. The advent of the Bukit Taga sanitary landfill is an endorsement of the government of Malaysia's commitment to modernizing solid waste management. KUB Berjaya Enviro developed the Bukit Taga sanitary landfill to achieve world-class standards in operations and maintenance, as shown in the provision of the top-notch leachate treatment plant, landfill gas management system, and attendant infrastructure such as the dedicated trumpet interchange at the North-South Expressway. The free beds and zero discharge practices are also unique to Bukit Taga. Bukit Taga Sanitary Landfill has attained the Gold Award of Special Merit for Environmental Engineering by the Association of Consulting Engineers Malaysia, the Engineering Excellence Award by the Institute of Engineers Malaysia, and the ASEAN Outstanding Engineering Achievement Project Award 2008 by the ASEAN Federation of Engineering Organizations. These achievements underlie KUB Berjaya Enviro's aspiration to be a major provider of solid waste management solutions with due consideration to environmental protection. KUB Berjaya Enviro's success in designing, developing, and operating the Bukit Taga sanitary landfill as the premier sanitary landfill in the region places it in good stead to achieve this goal. Let us share our experience with you.
Okay, thank you. I hope everybody has some idea what landfill facilities is all about. Pak Abdul, is this my slide from my computer or from your computer?
No, I think it's better from you, Pak.
From my computer.
Yes.
Okay. Where is sorry. Let me share screen. Okay, let's continue, right? Oh, sorry. When we talk about this municipal solid waste, okay, I'm referring to items that we discard every day, such as paper, plastic, glass, food waste, textiles, and so forth. So this solid waste or municipal solid waste, there are three general approaches to deal with waste. First is by burying the waste. Second is by burning the waste. And third is by recycling the waste. Burning the waste, okay, especially by open burning, should be strictly prohibited because this open burning will cause serious environmental pollution. Okay? And I believe every country has its own law to prohibit such activities. In addition to open burning, to burn the solid waste, some countries, they apply or they use incinerators. These incinerators, which is considered as a clean technology to burn waste, but we have to bear in mind that this incinerator will not completely destroy the waste. There are certain or some residues still need to be taken care of and to be disposed of somewhere else. In addition to that, the technology of incinerators, the cost of operation, the cost of maintenance are among the factors that hinder or prevent the utilization of this incinerator, especially in developing countries, because it's very costly. Right. In addition to this burning, whether it's open burning or by incinerator, then we refer to the tagline of 3 Rs. Okay, 3 Rs. I'm referring to reduce, reuse, and recycle. Okay, even though this 3 Rs tagline is aggressively promoted, right? But at the end, there are still solid waste to be taken care of, or residue or solid waste to be disposed of. In the case of Malaysia, okay, which produce about 40,000 tons of waste daily, okay, only 5% of the waste are being recycled. And in addition to that, when we talk about these 3R, reduce, reuse, and recycle, at the end, we can no longer practice this 3R, right? Because at the end, we still have residue to be taken care of. So based on this brief description of the scenario with regard to this municipal solid waste, we can observe that landfill facilities, as in the case of in the video just now, is still relevant or still needed to cater for the municipal solid waste. And in this landfill facilities, to store the solid waste must be designed and constructed accordingly so that the waste that being stored in the landfill facility with the associated complex biological and chemical processes will not pollute the environment. Okay, as I mentioned, landfill facilities are still relevant. Okay, so in Malaysia in 2016, here Abdul Rahman Dahlan, he was the Minister of Urban Wellbeing, Housing and Local Government in the previous government. He said that Malaysia still need landfills, and the government not keen to use incinerator. Then, in Malaysia, how many landfills? Up to date, we have about 140 landfills, which include about 21 sanitary landfill, and then 174 were closed. Okay. In addition to that, as I mentioned previously, the waste generation in Malaysia is about 40,000 ton per day, and in average, one person produce about 1.2 kilogram of waste. Okay, this is the map of state of Johor, right? And UTM is located somewhere here. And the nearby landfill facilities is located at this number 12, which is known as Silong Sanitary Landfill. In the state of Johor, we have 13 landfill facilities. Okay, in terms of history in Malaysia, okay, in the 80s, about 30 or 40 years ago, Malaysia had a problem with this problem of solid waste management. They just dump the waste by open dumping and then by open burning. See, you can see the smoke. And then due to the improper landfill facility, so the generated leachate contaminate the environment by flowing into the river or flowing downward and contaminate the groundwater. In addition to that, due to the improper sanitary landfill facilities here, it create a bad smell as well as create hygiene problem due to the proliferation of disease vectors such as flies, birds, and so forth. So in 1987, the government of Malaysia requests assistance from the government of Japan in managing the solid waste, what we call it is municipal solid waste. So in 1988, JICA, known as Japan International Cooperation Agency, sent his personnel to assist Malaysia in dealing with this solid waste management. So the site selected was in Seberang Perai in Penang. Okay, so the personnel sent by JICA was Professor Yasushi Matsufuji, right? This is the guy. He came to Malaysia and assist Malaysia in dealing with a solid waste management system or problem. So from their discussion and so forth, they found out that the main problem in Malaysia in dealing with the solid waste management system were money, material, and manpower. This is what we call 3M. Without money, they couldn't purchase material. Without the material, they couldn't construct the proper landfill material at the same landfill facility. At the same time, we have workers, but without expertise. So that is included in the manpower. So the Japanese helped Malaysia in dealing with all this problem. So as a start, okay, they used the available local material such as bamboo, and then they drill hole along this bamboo to create a leachate collection pipe. Okay? So the leachate will flow into this bamboo, and this bamboo will convey the leachate into the leachate collection pond. In addition to that, they use used metal drums to create what we call the semi-aerobic system in the landfill facility. So this photos shows the constructed semi-aerobic system. So we can see the bamboo here, right? So the bamboo will convey the leachate to the main bamboo, the main pipe here, and the main pipe will convey the leachate to the collection ponds. So based on this improved system, helped by or assisted by the Japanese or professor from Japan just now, we could see that the quality of leachate being generated from the landfill facility was improved. Okay, and the photo here we can see that the what we call the filtering of the leachate and then recirculating the leachate. In this case, it was done manually. Okay, so they get the leachate from the leachate collection pond, and then they filter the leachate, and then they put back in the waste in the landfill. The purpose of recirculating the leachate is to have further biological and chemical processes within the waste in order to improve the quality of the leachate to be generated. Okay. So the cooperation between this Malaysian government and the Japanese government continues, whereby there are several documents have been produced, such as the guidelines on development and operation of sanitary landfill, the landfill closure guidelines, and so forth. Okay, that's based on the from the Japanese. Okay, when we talk about this sanitary landfill, before I talk about this compacted soil liner, I have to give a brief description about the landfill, the classification landfill and the component. Then we go to the compacted soil liner. Okay, there are 4 levels of sanitary landfill. Level 1 is the most what we call the most like a conventional or the most orthodox, right? Just dump the waste and then they just spread the waste. Okay, just waste without any proper treatment system. Okay, without any cover. Right. Level 2, a little bit improvement. Let's say the landfill area is a flat area, then they construct earth band to form what we call retaining structure to contain the waste. So this retaining structure or band will prevent the waste from collapse. And then at the end of every day operation, they will cover the waste with soil in order to maintain the hygiene of the waste. Level 3, further improvement, they have leachate recirculation system. Okay, just like in the photo previously, they filter and then they put back in the waste the leachate into the waste for further biological and chemical process to improve the quality of the leachate. And level 4 considered as the most complete. So the sanitary landfill equipped with leachate treatment system, leachate collection pond, proper lining, proper cap, proper gas monitoring system, and so forth. Okay, so those are the 4 different levels of sanitary landfill. And then we talk about this engineered landfill. When in the operation of engineered landfill, the waste being disposed of at this landfill must be controlled. For example, only certain types of waste can be disposed of in these landfill facilities. For example, the hazardous material or flammable material cannot be disposed of in this landfill facility. In addition to that, the waste collected from the community, transported from the community to this landfill area can only be dumped in a specified cell. Even though we have large landfill facilities, but they have to dispose the waste at specified cell. After this cell is full, then they open the new cell and then they can dump the waste into the new cell and so forth. That's what we call control method of waste disposal. And this engineered landfill should be designed and constructed to form the bottom liner and cap in order to store the waste, okay? To encapsulate the waste to prevent the leachate from contaminating the environment. It could be gas, it could be leachate, again. And then in terms of the concept of landfill facilities, it's important that we have to remove the solid waste immediately from the community and brought to the landfill facilities, compact them to make sure the waste is stable or stabilized in terms of physical and in terms of chemical, right? So will not cause pollution to the environment. So in terms of the type of treatment or type of process to be developed in that landfill facilities, we have to consider a few factors such as the geographical area. It should be placed away from residential area. Just like in the case of Bukit Taga, it's located about 50 kilometers from the city center, from the residential area. So as we know, nobody wants landfill facilities to be constructed behind their backyard, right? In addition to that, the financial, depending upon the financial, then you can select which type or which system to be used in the landfill facility. Level of technology, again, do we have the technology? Do we have the expertise to operate the system? So those are among the factors that need to be considered in selecting the treatment process. Okay. In terms of the landfill facilities, there are several components need to be installed in the facilities to ensure the effectiveness and the efficiency of the landfill facilities. For example, here, in terms of operational facilities, they should have retention structures like bund, lining system, drainage system, leachate collection system, and so forth. I'll talk about later on. Okay, and then in terms of the management facilities, should have admin office, should have weighbridge. So based on this photo, which I took from this Silong website, okay, Silong website, this is the entrance, and let's say the garbage truck carrying the garbage or solid waste to the landfill. So they have to go through this weighbridge, and then the weight of the waste should be recorded because it's a control method of disposal, right? And then we have at the back here is the administration office. In addition to that, for the supporting facilities, like access road, of course we need access road. Otherwise, how are we going to transport the waste from the community to this landfill facility? Fencing around the landfill area is in order to prevent scavengers from going into the landfill. And scavengers, they go into the landfill and then they just try to collect the valuable material that being disposed of. In addition to that, you need to have workshop, fire prevention system, because landfill facilities is prone to fire hazard due to the liberation of methane gas. Okay, some of the component here. On the right here, we have compacted soil liner. The soil is being compact to become a liner, just like diapers. Baby wear diapers to contain their waste, right? And then in addition to compacted soil liners, some landfill facilities are designed to use geomembrane material or geosynthetic material, which is impermeable because we want to prevent the leachate from migrating downward. So we need to have liner system. Could be compacted soil alone, or the combination of compacted soil and geomembrane. So I have a sample of geomembrane. This is a sample of geomembrane. It's produced from based on plastic industry. Okay, it's impermeable, flexible, impermeable. Right. Okay, the photo in this in the middle here. Let's say the landfill area is flat. Okay. In order to contain the waste, they construct this retaining structure or earth bund. So by having this earth bund, waste can be disposed of here, and this bund will prevent the waste from collapse. Okay. If you remember from the video, at the end of every day of the operation, soil will be used to cover the waste. Okay. When the waste is disposed of, then they compacted. At the end of the day, soil will be transported and placed on top of the compacted waste to cover the waste. But the use of soil, right? The use of soil where we have to, maybe we have to import from somewhere else, or maybe we have to dig nearby the landfill facility. But we can consider the use of soil to cover the waste is considered as non-environmental friendly because we have to excavate here and there, right? So some operators, okay, instead of using soil, they use plastic sheet to cover the waste, just like in this case. So the cover is to prevent rainwater from entering the waste, which will increase the leachate generation. Okay. Okay, these photos I took from this Silong sanitary landfill. This is during the construction to provide this stormwater drainage system. At the bottom here is the leachate treatment plant, and here we can see waste, right? And then we have sea excavator on top of that. Maybe they spread the waste and then they compact the waste to make it to reduce the volume so that more waste can be placed in this landfill facility. Still the component of this landfill, right? So on top, if you remember the previous slide, we have compacted soil liner, and then we have geomembrane. Okay, the black material, the black sheet here is the geomembrane. So on top of the geomembrane, normally they place gravel to act as drainage layer. In addition to that, they place this leachate collection pipe, perforated leachate collection pipe. So along the pipe here, they have holes so that leachate can flow into this pipe. So after they place this gravel or drainage layer, then the waste put on top of this gravel or drainage layer, the leachate generated will flow through this drainage layer into the pipe, and this pipe will collect the leachate and convey the leachate to the leachate collection pond, just like this. See the black color of the leachate. You can imagine how it smells, right? So from the leachate collection pond, still into the component of landfill facilities, from leachate collection pond, the leachate will be conveyed to leachate treatment pond. It's similar shown in the video from this Bukit Taga landfill facilities. This is these pictures show the typical activity, daily activity in landfill. So this is just a sample, right? Tipping of waste, and then spreading of waste and compacting the waste. Right. I took this figure from a textbook because I don't want to spend time to draw again, but the concept is similar, right? So the landfill components should have bottom and lateral side liner system. So here, at the base here, the bottom liner system, and at the side here is called side liner system. Okay, if you refer to this figure, if you look at the figure, we have a double composite liner system. One here at the bottom, we have compacted soil liner. Below this is the foundation soil, and then the first layer of compacted soil liner, and then we have geomembrane. On top of the geomembrane, we have leachate collection pipe, and then we have gravel layer as drainage system. Then on top of this gravel, normally they place a geosynthetic to separate between the gravel and the compacted soil layer. See the compacted soil layer, and this is the geomembrane. This is a drainage layer with this leachate collection pipe. They place the waste here, and then the generated leachate will flow downward through the gravel and into the leachate collection pipe. Let's say the geomembrane leak, then the leachate will flow downward, but we have here compacted soil liner, so we'll reduce the reduce or decrease the flow of the leachate downward, right? So next is a leachate collection system or removal system. Here, the drainage system and the leachate collection pipes, gas collection control and system. Here we have a vertical pipes, perforated pipe. So the gas generated here will flow into the pipe here and go up, and the gas will be collected and processed, right? If to generate power, as mentioned in the video just now. Final cover system at the end of the operation. Okay. The waste should be covered. This some of an example of the cover or top liner system, right? To cover the waste should be covered so that rainwater will not infiltrate into the waste, because if rainwater infiltrate into the waste, it will increase the generation of the leachate. On top of that, we have stormwater management system. Okay, we have to manage the stormwater to prevent the water from going into the waste. Similar in the case of rainwater. Try to avoid the encroachment of the water into the waste, because it will increase the generation of leachate. Groundwater monitoring system. Normally they have a well here to check the quality of the groundwater. So if the quality of the groundwater deteriorate, become worse due to the leachate, maybe because of the leakage, then they have to do something, all right? And then they have, of course, they have gas monitoring system. Okay, these photos I took from this Berjaya. Okay, they have only single. They have here foundation soil, and then they have compacted soil liner. They have geomembrane, and then they have drainage layer, and of course they have leachate collection pipe. Something like this, right? Compacted soil, and then they have different layers of geosynthetic, right, to prevent migration of leachate, and then to prevent the mixture of gravel and the compacted soil liner. So they have to put different layers of a geosynthetic, and then here we have leachate collection pipe, waste, leachate generated by this waste flow downward into the pipe and convey to the leachate collection pond. The purpose of having a liner, okay, the purpose of having liner is to restrict or to stop the migration of fluid. It could be leachate, it could be gas, right, from landfill facility to the environment. Again, just like a repetition, we have caps to prevent rainwater from going into the waste, which will increase the generation of leachate. In terms of the liners, there are 4 different class of liners. One is what called soil earthen liners. This is the thing that I want to talk about later. And then the geomembranes, geosynthetic clear liners, and vertical cut-off walls. Pak Abdul, how long I have time remain?
Okay, Pak.
How long?
It's still, I think still 5 minutes left.
How long? I have 10 minutes, 20 minutes left?
Okay, it's 10 minutes, it's okay.
10 minutes, okay. In that
yeah.
case, I have to speed up, okay? I have to speed up
Yeah.
in the construction of what we call compacted soil liner, right? So in developing the compacted soil liner, so we have to choose the right soil type. In the construction of compacted soil liner as the bottom liner or side liner of the landfill facilities, normally they use what we call sheep foot roller. Sheep foot roller. So the sheep foot here, they call sheep foot like goat, right? Sheep foot. So the result will look like this. Compared to this is what we call smooth wheel roller. This is sheep foot roller. So the foot will penetrate into the ground and cause additional shear to the soil, and the result is decrease in permeability, because we want this compacted soil liner, the permeability is very low to prevent the leachate from migrating downward. So we have to properly compact and make sure the permeability is low. So in the construction of a compacted soil liner, normally the thickness is about 1 meter. So the soil leaf need to be placed every 150 mm compact using this sheet full roller, and then place another layer of 150 mm compact again with this until we achieve about 1 meter thick. So at the end, this smooth wheel roller will be used to create smooth surface on top of the compacted soil layer. Should be smooth, because after that maybe we have to place the geosynthetic or the geomembrane. In order to properly place the geosynthetic sheet or the geomembrane, we have to make sure that the compacted soil surface must be smooth, not with holes like this. Yeah? You see, this one is only below the surface in order to create low permeability compacted soil liner. In addition to that, by having these holes, when we put additional leaf, it will cause interlocking between layer. If we compact using this smooth wheel roller, so the surface will be smooth, and then we lay another leaf, so there will be a gap between the bottom layer and the top layer. There's a interface. It will cause sliding something, or maybe it cause because the permeability between the two layers is large, so it's not desirable. Okay, this is the smooth compacted soil layer, okay, soil liner, and on top of this, they may place this geosynthetic or geomembrane, depending upon the budget. If they have the budget, maybe they can place this geosynthetic. If they don't have the budget, then maybe they just use compacted soil liner alone. Okay, see this about similar. Another type of liner that can be used is what we call GCL, geosynthetic clay liner, something like this, okay, or something like this. So this geosynthetic clay liner consists of two geosynthetic, something like this. This is geotextile, okay, geotextile, just like a geomembrane, okay, geotextile. We have two layers, right? So in between these two layers, they place clay, normally bentonite. This bentonite is a type of clay mineral. When in contact with water, it will expand and become impermeable. That is desirable because we want our liner to be impermeable to prevent leachate from migrating downward. So in this case, in this figure, you can see the laying of this GCL, geosynthetic clay liner. So on top of this geosynthetic clay liner, again, like just before, they place this gravel layer as drainage layer. Okay, this at the bottom here is another figure of a GCL, geosynthetic clay liner. I don't want to talk about this because time, okay, time constraint. Right, for soil to be accepted as compacted soil liner, it must fulfill three criteria: permeability, swelling shrinkage, and shear strength. The permeability should be less than 10 to the minus 7 centimeter per second. Okay, all the criteria we refer to guidelines produced by developed countries like USA, like Japan, like Australia, like European countries. Okay, so we refer to their guidelines and then try to suit with our soil. Okay, so in terms of permeability, it should less than 10 to the minus 7 centimeter per second. In terms of shrinkage and swelling, so these are the samples that we produce in our lab, right? And then in order to monitor the swelling and shrinkage, the compacted soil samples were placed in the lab exposed to the atmosphere, and we measure every day the diameter and the height in order to observe the change in terms of volume. So we stop measuring when there were no longer change in terms of a reduction in the diameter and the height. So the VSS here, volumetric shrinkage and swelling, can be calculated as the initial volume minus final volume divided by initial volume times by 100. So should get less than 4%. If more than 4%, then it does not fulfill the criteria. Similarly, for the strength here, we test the compacted sample using unconfined compressive strength test. And based on guideline, the unconfined compressive strength should not less than 200 kPa. Okay, if the strength is less than 200 kPa, then it's not acceptable. So in the case of permeability, back to the permeability, the two types of tests, right? We have constant heat permeability test and variable heat permeability test. So we use variable heat permeability test because this type of test suitable for fine grained material. In terms of the soil liners, okay, should use inorganic clays or clayey soils. Should be highly plastic clay, low plasticity clay, or clayey sand. And then if the clayey materials are not available, we may add the existing soil with bentonite. Okay, bentonite, as I mentioned, like in the case of geosynthetic clay liner, when in contact with water, it will expand and become impermeable. This is another guideline produced by Lutton in 1979. Based on this volume change with change in water content. So the preferred criteria here is when the PI between 0 to 30% and the shrinkage limit greater than 12%. Other than that, the change in volume or shrinkage and swelling based on this criteria are not acceptable or not preferred. Okay. Okay, when we perform this compaction test, there are three types of compaction tests need to be performed on that candidate of the soil sample. Okay, this is based on method proposed by Daniel and Benson. So we have standard proctor. Everybody knows what standard proctor is, right? We have, let's say, sample with a mold with about 1 liter, and then we put sample that we mix with water, 1 layer, and then we apply a blow of hammer weighing 2.5 kg, and the drop is about 300 mm. So we apply 25 blows per layer. So 1 layer, 25 blows, and then another layer, apply again 25 blows, and another layer, 25 blows. That is a standard proctor. This is what you have learned in soil mechanics class, I guess. Right? Modified proctor. So we have to perform modified proctor on this soil sample, again using this similar volume of mold, and then, but in this case, we use 4.5 kg hammer instead of 2.5 kg. Okay, 4.5 kg. Number of layers, instead of 3, become 5. 25 blows per layer, and the drop distance is 450. Meaning, the modified proctor, we applied higher energy per volume of soil compared to standard proctor. And another one is the reduced proctor. Reduced proctor, 3 layers, just like a standard, but the number of blows is reduced. Instead of 25, become 15 blows. And the hammer use is 2.5 kg, drop distance 300 mm. And then, as usual, we have to calculate the dry density of each sample. Okay, the picture just shows this hammer hammer to be used in compacting the soil manually, and this is the automatic compactor. Right, let's see. This figure shows the result that we obtained from our compaction test. Right, remember that we have to fulfill 3 criteria: permeability, volume, swelling and shrinkage, and another one is strength. So we have 3 different compaction: standard, modified, and reduced. Okay. So in this case, it's recommended that we perform compaction for each type of compaction. Let's say for this reduced compaction method. Okay, we prepare 5 samples, right? So we compact, and then we have to repeat compacting using this reduced sample another 5 sets, because imagine for each permeability test, at least we require 2 samples, and then we take the average of the value of permeability test. Let's say, for example, here for at 25% for reduced Proctor. So we need to test on permeability, we need to test on strength, and then we need to test on the volumetric shrinkage. So 3 tests times 2 becomes 6. So prepare 6 sample at this moisture content for reduced Proctor. Similarly, 6 sample minimum to be subjected to this compacting reduced Proctor with this moisture content and so forth. Similarly for the standard and modified. Okay, and then let's say we took sample and then we test the permeability for each criteria in terms of this reduced Proctor, standard Proctor, and modified Proctor. And let's say this were the result. Okay.
I'm sorry, Pak Kamarudin. 2
Yep.
minutes left. 2 minutes left.
Okay, right. So we mark that fulfill the criteria, the sample that fulfill the criteria in terms of permeability must be less than 10 to the minus 7 here. So we mark the point that located below this below this 10 to the minus 7. So we mark here. So this is for the green one is the modified. Here, oh sorry, how to my, okay, this is, okay, this is accepted, and accepted, okay, and for this standard, the second one, 1, 2, second one accepted, third accepted, fourth accepted. So for the standard, 1, 2, 3, 1, 2, 3, right? In terms of the permeability, and then for the reduce, in the reduce, none is accepted. So we can approximate the zone of acceptance is around here. Okay, right. So we color the zone of acceptance in terms of permeability. Then we go for this volumetric shrinkage. Those above the 4% are not accepted. Only below 4% are accepted. So we mark the points that are accepted in this figure on the left. Where is my okay? And then we can shade the region that is accepted. Okay, something like this. Okay, okay, that is the region that consists of point that being accepted. Next, we go to the in terms of the strength. So above the 200, okay, above 200 here, above 200, this point I accepted, except this one. So in this case, this one not accepted. So the accepted points are here. Okay, right. Okay. Then at the end, we superimpose each shaded area in order to get the overall accepted zone here. First is the strength, then the shrinkage, then is the permeability. So the area that cover the 3 main criteria in terms of permeability, in terms of shrinkage, in terms of strength is shown here. Right? This is the acceptable zone. Meaning when we check the compacted soil at site, it must fall within this zone, this area. So when we check the compacted soil at site that do not fall within this area, meaning that sample must be rejected and must be modified. Could be add moisture content or could be recompacted in order to fulfill all the 3 criteria in terms of permeability, volumetric shrinkage, and shear strength. Okay, these are the method to check the dry density, right? Using what we call the sand cone replacement method, and then this is what you call double ring infiltrometer to check the permeability of compacted soil at site. So because of the time constraint, I have to end my presentation here. Thank you very much for listening, and again, thank you to the organizing committee for giving me the opportunity to share what I have learned from this event. Thank you very much. Back to you, Pak Abdul.
Yeah, thank you very much, Pak Kamarudin,
Yes.
for your interesting presentation. Now it's time to question and answer, but unfortunately, we only have 5 minutes left. So I think only one or two question, I think. So anyone want to ask Pak Kamarudin, please? Okay. Waiting
How
for,
to see the question?
yeah. So I think the question, the first from me, Pak. Okay. Pak Kamarudin, you told the garbage for the solid waste. My question is, out of the what have you presented in Malaysia, is it safe to use the carpet as foundation, Pak?
To use what?
Foundation.
What? To use what in foundation?
For the foundation, Pak. Because I see also the layer of garbage, it's what used with the soil, and it can be used for the foundation. Is it okay or not, Pak?
If I can see, I can read how to read the question. I'm not quite sure what the question is. How to read the question?
Okay. The carpet itself, Pak. The garbage, because
The
we
what?
know
The what?
garbage, garbage, garbage,
What?
solid waste, garbage.
Uh-huh.
Yeah,
Solid waste, huh?
yeah. Is it okay to use it for the foundation?
Oh, to use the solid waste as foundation material.
Yes.
Oh, I see. Okay. So we have to bear in mind that solid waste normally consists of different materials like organic material, inorganic material, and so forth, mixture of materials, and it may decompose with time. So I would say that when it decomposes, it will settle because of it reduced in terms of volume. So it's not suitable. It's not suitable to be used as the foundation material because it will decompose and it will settle with time. Normally for this solid waste, for this in the landfill, they don't construct structures on this waste because of that, right? Because of the composition process as well as because of the settlement, and in addition to that, the hazardous gas, the generation of hazardous gas may create fire hazard. Okay. I hope I understand the question and I hope answer the question.
Okay, thank you, Pak.
Yeah.
The second question, Pak, is still from me, Pak. From your research,
Yeah.
we know the type of soil for the soil liner is for the permeability coefficient less than 10 minus 7.
Yeah.
So I think with the another requirement that the shear strength should be more than 200 kilopascal. I think it's not easy when we
Yeah.
use only pure clay. So it means that we have to mix with the bentonite, Pak.
Okay. Actually, there's only a guideline. It depends on the available material and it depends on the design of the landfill or the liner facilities itself. Because if the strength is not achievable, 200 kPa, right? Less than 200 kPa, maybe we have to place the waste less height. if 200 kPa, let's say we can put 20-meter height of waste. So let's say we have only 150, maybe we reduce the height of the waste in order to make sure the foundation or the liner is safe, not fail due to the weight of the waste. And the addition of bentonite is actually to reduce the permeability. It will not increase the strength.
Okay.
I hope I answered the question. I hope I understand the question.
Okay. Okay. Thank
Yeah.
you, Pak. Thank you,
Yeah.
Pak. So because we have a limited time, Pak.
Yeah.
So and
Yeah, because
also
of the problem with the video just now.
yeah, yeah.
Spend more, yeah.
We have a problem. We have a problem in the early. Uh, uh, so please, Pak, for the closing remark, Pak, please.
Okay. Again, I would like to thank the organizing committee as well as the participant for participating in this event. I hope this kind of a short course can be continued in the future, because internationally, because from there we can share our knowledge, we can share our experience with different people from different geographical area. Okay, with that, I would like to say again, thank you to the organizing committee. Thank you, Pak Abdul. Back to you.
You're welcome, Pak. Yeah, inshallah, Pak. Inshallah is
Inshallah.
the first our program, so
Yeah.
we will continue in the next future.
Okay.
Okay, thank you very much. Thank you, Pak Kamarudin, for your interesting presentation. Okay, so it's the end of the session. So thank you very much for all the participants for still joining us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much from Professor Kamaruddin bin Ahmad and the moderator Mr. Abdul Rahim has delivered interesting material that talking about completed soil linear for landfill facilities. And then as we know, we has delivered from Mr. Kamaruddin, Professor Kamaruddin, that what is geotechnical soil and then what is the type of criteria of geotechnical soil.
Here we come to the last lecture of the day. We'll discuss about floating construction by Dr. Roger de Graaf from Netherlands and the moderator, Dr. Henny Pratiwi Adi, STMT. Please welcome to the Dr. Roger de Graaf and Dr. Henny Pratiwi Adi, STMT. Time is yours.
Thank you very much for your kind introduction and for inviting me to the RMI week. It's a great honor and pleasure to speak to you about my topic, floating urban development, that I've been working on in the past 16 years.
Sorry for Dr. Roger, please wait Dr. Henny to open the discussion.
Good, thank you. Yes, please.
As a moderator.
Okay, thank you. Hello, Dr. Roger.
Hello. Good afternoon. Good morning.
Good afternoon.
Nice to meet you.
Good afternoon. Okay, I will open this session first. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Henny Pratiwi Adi. I'm a moderator in this session. Okay, as an introduction, today's climate change is a major issue in the world, which become a serious problem in many countries. The climate change is characterized by increasing temperature in the atmosphere, rising sea level, and the degree of ocean acidity. In general, the impact of rising sea level is the inundation of lowlands, increasing coastal erosion, and causing seawater intrusion to mainland. And the impacts disturb people's activities, damage residential building and infrastructure building. And dealing with a water-related issue was always been a challenge in many parts of the world, especially in high-density areas along river near the coast. That's the Delta City. With the rising of the sea level, climate change and land subsidence, Delta City have to adapt to changing condition in order to keep the city safe from flooding. Only extend the embankment in this situation is not enough. A combination of different solutions must be applied, and floating construction is an alternative innovation solution to adapt to rising sea levels. And in this very special occasion, that is the first international short course program entitled Resilient Mitigation and Infrastructure Week, was present with us Dr. Roger Ewood de Graaf van Dinter. Is it right to say?
Perfect
Roger.
pronunciation.
Okay.
Thank you very much.
Okay.
Yes.
He is the director and co-founder of Blue 21. And Blue 21 is a high-tech company fully specialized in the development and application of climate-proof floating construction technologies for housing, energy, logistic, and food production in project in the Netherlands and abroad. Okay, please allow me to read our speaker curriculum vitae. Dr. Roger was graduated for his master program and PhD program with cum laude from Delft University of Technology. And he has work experience in many kind, like applied research professor in Rotterdam University of Applied Science, director and co-founder Delta Sing, and then co-founder, board member, and chairman of Blue Revolution Foundation, and other. And also he has many awards from many sources, I think, and also have so many book and chapter and publication, yeah, journal publication. So it was very great CV, I think. Okay, ladies and gentlemen, now we have immediately start listening to Dr. Roger presentation. And for Dr. Roger, you have 45 minutes to present your paper. So the time is yours.
Thank you very much, dear moderator, for the wonderful introduction. And it's a great honor and pleasure to be here today and to join the RMI week of Unisula. And it's wonderful to share some of my work with the students and the researchers. Also, I understood from Dr. Floris Bogaert that it was a very good session yesterday. And Dr. Floris Bogaert and me, we worked together already for a very long time in a different field on floating, but also the water quality. So he's a great friend and colleague. And I'm very happy that he introduced me to this very interesting week. So then I will share my screen now and show the presentation that I prepared for you. And I will, of course, try to stay within the time that you have reserved for me. So let's make sure that works out. Thank you very much. Then I will share my screen. And I hope you can all see my screen. I think I see it in the hybrid talk show.
Yes,
I see myself talking and I see the slides, so that looks good.
Yes.
Thank you very much. I will talk today about the topic land from water. I will talk about technology, design, but also the governance of climate resilient floating urban development as part of the international short course. My lecture outline is that I start with a quick introduction. And then I will talk about the vision. Why do we need floating urban development and why do we need it now? What's the urgency? I will talk about the technical feasibility of floating structures. I will talk about subsequently about the environmental impact and regenerative design. Then I will talk about governance and socio-economic acceptance. and how we can strengthen transformative capacity. How do we move forward? And I end with the conclusions, and I hope there will also be some time also for question and answers from the students or the teachers and researchers. So that brings me to the introduction. A little bit about Blue 21. This is our team. We're highly specialized, so we work every day on floating urban development. It's the only thing we do already for more than 50 years. And we have a very interdisciplinary team that includes architects, urban planners, but also maritime engineers, civil engineers, people more, and environmental issues. So very interdisciplinary group. And I think that is also what we need if we want to move from the dream to project. So our company is specialized to start with a dream, but in the end also to be pragmatic. What can we build? What can we build today? What can we build tomorrow? We have partnerships with world-leading knowledge institutes, companies and investors, such as the Maritime Research Institute in the Netherlands, MARIN, but also TU Delft. We received an investment from Buxeris Capital. We have a very close working relation and partnership with Shimizu Corporation from Japan, one of the biggest contractors from Japan. We work in the Helsinki area on the Finest Bay. We work with Indaimo. I think Vlog Spookhaar told about that as well. And also with the Global Center of Adaptation and the City of Rotterdam. And of course, the network and a partnership is what we need if we want to make a real impact on society. So why do we need floating urban development, and why do we need it now? Why is it very important today? I think if we look at the global challenges for 2050, we see that most of the urban space will still need to be built. So the total urban space in the world will more than double, even already before the end of the century. At the same time, we see a projected sea level rise and more extreme weather, resulting in more extreme river flows, more extreme rainfall, flooding events. At the same time, we see that already today, 50% of the global population is living very close to the coast. And this percentage is increasing. So more and more people move to the coast. And then, of course, we see a rising population and an increasing land shortage. So we have estimated that the future land shortage already in 2022 would be in 2050, sorry. So that's less than 30 years from now. We estimate to be around 22 million square kilometer, and that would be around the same size as the total land area of North America. That we need for food production, but also sustainable energy for growing cities. So we think these three global challenges are quite big, and we need to think in an innovative way to deal with these challenges. And this has also been acknowledged by the Research Institute Deltaris in the Netherlands. They have translated the IPCC report for Europe, but for other continents such as Asia, I think we see the same things. We see more floods, more heat, effect on droughts, nature, of course, the effect of climate change on agriculture. And we also see that the cities are the hotspots. So the cities is where all these effects come together and are strengthened. So in particular, in urban areas, we need to think in different ways how we can transform our urban areas to become less vulnerable to climate change. I've written this book. I coordinated this book and wrote it together with other experts. And we have identified 5 different capacities that we need to become resilient to climate change. And the first one is a threshold capacity. It's basically what we have done in the Netherlands for a long time, building dikes, building a threshold against flooding, for instance. But of course, as we face more extreme floods, still there might be occasions when we still have to deal with the flooding, and we need to strengthen the second component, which is the coping capacity. So if there's a flood, we need to cope with the flood, and we need to try to reduce the impact of the flood. And of course, after the flooding, we need to be able to recover. So we want to recover to the same situation as before the flood, or maybe even a better situation. And of course, if we're able to recover from flooding, we become less vulnerable and we become more resilient. And then, of course, we need to deal with uncertainties in the future. So how do we deal with climate change? We know that climate change is there. We're certain about it, but we don't know the exact impact. It can be worse. We hope it's better, but we see that the predictions are getting worse. We don't know exactly how much sea level rise we will see at the end of the century. And then, of course, adaptive capacity is about building different options to prepare us for this uncertain future. And floating urban development is, of course, one of the technologies that can be applied to become more adaptive, because it's a way to also adapt to a future higher sea level. And then the fifth one is transformative capacity, and that is in face of all these challenges that I've shown, how can we also transform our society? How can we transform water management? And are we able to also address the root causes of the climate change by able to work together through different sectors? How do we link urban planning to water management? And that's all has to do with the transformative capacity. And as is outlined in the book, Climate Resilient Urban Areas, is that not one of those five is most important. So they're all equally important, and we need to strengthen all of those five capacities to become resilient. Floating urban development is one of the technologies, not the only one, but it's a very promising and interesting technology that we can apply to become more resilient to climate change. So a new perspective is to create new space on the water. We have this big land shortage in many coastal cities in the world, and we could move to the water to build housing, floating housing, but also to create floating biofuel, floating seafood and fish, floating vegetables and crops, floating algae systems. So it's not only about the floating housing, it's also about logistics, it's about energy, it's about food. And of course, if you look to the left top of my graph, you see some other options that we have. We see that now cities are growing and sacrificing farmland, but of course we need the farmland for the food production. We also see cities are growing and sacrifice nature. That's also not such a good idea, because we are part of an ecosystem and the nature is already under stress, so we need to protect the nature. And we see that cities are moving into floodplains. And that happens in many areas, but of course that increases our risk. So if we expand a city in a floodplain, we will have more risk and more flooding. We think that high-rise building, moving higher up, you see it there also, it's part of the solution, but it's not the only solution. So we see that cities can move higher up. At the same time, we see the average density of cities going down as cities are growing. So we think that the option to move underwater is a very promising and important perspective that we also need to take into account when we think about the future of urban areas. And so cities are already doing that, but most of them are looking to land reclamation. So many cities all around the world, they create new space on the water, but they do it by putting a lot of sand in there, by dredging and land reclamation. So that's an option that's applied now, but we see that there's a global scarcity of sand, and we also see that the mining of the sand and also the applying of the sand has a negative global ecological impact and also less social acceptance. If we look at floating development versus land reclamation, we see that floating has a number of interesting characteristics, such as floating developments, they adapt to the changing sea level, whereas land reclamation require dikes if the sea level will increase. We also see that for floating developments, we don't need sand, so it's less disruptive to the environment. And we also find that floating projects and floating structures can be prefabricated elsewhere, and then they can be towed to the final location, as you see here. So with the boats, you can bring the floating structures to the final location. And therefore, you can apply them very fast, compared to the very long and large timescales and long construction periods of land reclamation. Other benefits is that it's a scalable way of construction, it's resistant to earthquakes and tsunamis, very important, and that we can apply it also for ecological habitat creation. Whereas the land reclamation, we need very large capital investments, we see detrimental impacts on corals and marine life, and there's still also potential dangers of soil liquefaction. So we think that floating has a number of benefits. At the same time, I also want to stress that in many projects, floating and land reclamation can work together in the so-called hybrid solutions. So as you can imagine, land reclamation can create also protected water conditions that are very favorable for floating. And at the same time, floating breakwaters can protect land reclamation. So we also see potential in combining floating development and land reclamation. And in particular, the very shallow areas, land reclamation could still be a good option. But of course, the deeper waters, floating is much more interesting because you don't need any sand. So that's just to let you know, it's not a black and white story. So there's also the possibility to combine floating with land reclamation. And here you can see this is an illustrative example that our company did. And you see that in this specific case, that was published also in a report for the European Commission, that in the deeper waters, more than 12 meter, the floating becomes more attractive and cheaper. And in the shallow areas, we see that land reclamation is still the most attractive option. And of course, this graph looks different for every location. And so for Indonesia, we would have to look into the local situation, and that graph might look different. But in general, we see that in very shallow areas, land reclamation can be very attractive. And in the more deeper waters, the floating is more attractive. And of course, we also have the benefits of the ecological impact. Which brings me to the technical feasibility. So in this chapter, I want to explain to you that floating structures is not science fiction. It's possible already today. We have already many projects, and it's technically feasible to build these projects. Available structures that we have applied in the project that we worked on. You see on the left, you see combinations of polystyrene and concrete. This was done in the floating pavilion project that my company developed, our first company, Delta Sync, and in this case, the flex-base technology was applied. In the middle, you see fiber reinforced composites. So this is a combination of steel and composites that was applied in a floating housing project in Delft, the Netherlands. On the right at the top, you see the concrete floating platforms that are still often built. So these are hollow floating concrete platforms that you can use as a foundation for your floating building. And on the right bottom, you see the steel, which was applied in a very interesting project. And this is the Mega Float project in Tokyo in Japan, where a floating airport was made with steel hollow platforms that were being welded together. So these are 4 technologies that we often see in floating structures. And then the floating pavilion is our most famous project that we applied as a company. It's built in Rotterdam, and it's based in a tidal location, and it moves up and down with the sea level every day. And in the future, with sea level rise, the building will also adapt. Here you see some impression of the inside of the building. And here's some interesting construction pictures. At the left top, you see the polystyrene plates being put together. And then at the left bottom, you see in white, you see the polystyrene blocks. And in gray, you see a grid of concrete beams. And it's this combination of concrete and polystyrene that makes a very light, but still very strong floating foundation. And then at the right top, you see a steel construction being placed on top of that. And then we used inflatable cushions for the facade. So no glass, but very lightweight inflatable structures. And in the middle, you see me on one of the construction days to check if everything is going fine. And this building, the Floating Pavilion Rotterdam, was designed, engineered, and constructed in only 1 year. So it also shows that underwater, you can build very quickly. And I think that's also a big benefit of the floating. Another benefit is the possibility to relocate. So last year, the Floating Pavilion got a new location, and it was moved to the RDM campus of the Rotterdam University, location where I worked for 10 years. And also they worked together with Unisula already for a long time. And I think this is also a big benefit that with the floating projects, you can build them, you can put them to a first location, 10 years later, you can put them to a next location. And the Floating Pavilion is now used as an innovation area for students and researchers of the Rotterdam University. Also, last year we had a very big storm. If you talk about the safety of floating structures, this was 1 year ago in the Netherlands. We had a very big storm, biggest storm in 30 years. And on the right, you see the Floating Pavilion. And yeah, it's floating, it adapts to the water level and the waves, it hardly moves. And on the left side, the same day, you see in Rotterdam that the quays are being flooded. You see the cars are flooded. So this shows the comparison on the same day, like how a floating structure performs and what happens with the traditional construction. And of course, that's very important also if we talk to social acceptance. What is safe? And we think that floating structures can be sometimes even more safe than the buildings on the land. And of course, that's a very interesting perspective. This is a floating housing project that we built in Delft, our home city, where the citizens themselves designed their own floating house. Also some interesting construction pictures. You see on the left top, you see a steel skeleton. And on top of this steel skeleton is the skin of the fiber reinforced composite. And that creates a very light structure that you can build on the land. And then with a crane, you put it in the water. But it's not only about housing and buildings. This is a project that we did together with the Delft University of Technology, floating solar project. And you see that the floating solar panels are a little bit above the water so that the light can still enter the water and reduces ecological impact. And also on the underside of the floating solar panels is also solar panels. So the light that's reflected on the water is also captured by these solar panels. So how do you get to floating projects? Well, there's already many floating bridges in the world. So these are just some examples of very long floating bridges. These are the kind of structures that you can use also to go to floating projects. And here are some more, many in the US, but also in other areas where we have already seen the floating bridges as a way to also connect a floating city to the land. So to summarize, the building blocks are there. These are all existing projects that you see here, and not only of Blue 21, of course, also of other companies, but there are many applications, from floating walkways to floating housing to floating ports. Even in the Netherlands, we have a floating farm, a floating wind, floating solar, floating public buildings, breakwater, swimming pools. So there are many possibilities to create floating projects. So the building blocks are there, but the scale is still relatively small. So our challenge is, of course, how can we increase the scale of these kind of projects and make larger floating neighborhoods? So what we work on as Blue 21 is scaling up for housing, logistics, and energy. So on the left, you see a floating housing project that we designed for 50,000 people. And on the right, you see a floating container terminal that you could use for floating containers for ports and logistics. If we look at Rotterdam, we see also different applications. So here you see the historic development of the city of Rotterdam and the port of Rotterdam, still the largest port in Europe. On the right, you see the old ports that are now being gradually redeveloped for urban purposes. That includes floating urban development. In the blue parts, these are the port areas of the 1960s. They are now, we see a transition to more sustainable fuels. So you see the fossil fuels and the transition to the sustainable fuels, which opens opportunities for mobile synthetic fuel terminals. And on the North Sea, we see a big transition to the wind and hydrogen logistics, but also floating eco-reefs and other applications. And in the future, perhaps also floating city developments at sea. Of course, if we want to do this, we need a very sophisticated engineering. And if you're talking about very large floating structures, you can no longer apply the calculation methods of the shipbuilding, but you need to move towards hydroelastic calculations of floating structures. And this was written by Jan van Kessel in his PhD thesis at TU Delft. And Jan van Kessel established a maritime engineering division within Blue 21. And that followed by a couple of master theses as well. At TU Delft. So for instance, the impact of floating breakwaters, but also the hydroelastic analysis of very large multi-module floating structures, and also the impact of tsunamis on floating cities. So these are, of course, all very important topics that we have studied together with the TU Delft and students that worked on this. In our company, we use different calculation methods, such as the finite element methods for structural analysis. We use hydroelastic modeling. We have our own calculation tool, our own software, HydroMech Plus, which is an in-house tool where we can calculate the response of floating urban projects on waves and calculate if it's still safe and comfortable to do so. And these are the kind of animations. So this is the floating pavilion again. And we can calculate the effect of very extreme waves on the floating structures with our own software that we developed. Of course, software is one thing, but we also work together with the Maritime Research Institute in the Netherlands, where we do wave-based tests on the scale models. This was for a European project subsidized by the European Commission. And you see here floating blocks of solar, floating housing, but also now you see in the screen floating container terminals. And these are scale models that we can apply. So in reality, these units would be about 50 meters wide. And we can test the effect of the waves on these floating structures. And we can calculate the forces, we can calculate the movements. And then we can calculate if these projects are safe and comfortable. And this is, of course, important that we calculate it in computer. We validate with wave-based tests before we build it in reality. And I think that's, of course, always a strategy that we want to be sure that these projects are safe to build. We're not only talking about very large projects, we also investigate affordable floating housing. So how can we make floating housing not only for very rich people, but we make it accessible for everyone. So this is a design that we made for affordable floating housing. And also, of course, it's not only about housing, but also about sanitation and water treatment. We have done a lot of research. You see a small floating road there that's decentralized compact wastewater treatment systems, drinking water treatment. We have energy storage. So when you move to the water, there's also many opportunities to organize water treatment, water management, and also energy, and to become more sustainable when we move to the water. And that's a part of our vision as a company and also part of our technology. So that's what I wanted to show to you about the technical feasibility. And of course, very important, if it's technical feasible, what's the environmental impact? What is the impact of these floating structures on the environment? And we have worked with aquatic drones. So underwater drones that we have equipped with sensors. And also we measure different things like dissolved oxygen, also the conductivity. We can also measure LJ systems, the turbidity, the pH, and of course the depth profiles. And we have used these sensors to go under the floating structures and do research on the ecological impact and the water quality impact of these structures. And here you see some of the work that we have done with the aquatic drones, also in Indonesia, and other countries as well, Vietnam, Peru, also in Africa, a lot in the Netherlands. So this is a very sophisticated technology that we have applied. And this is a study that we have done, which was also published last year in the Journal of Water Climate Change, where we have done more than 6 years of measurements in more than 15 locations. And we go with the drones under the structure, near the structure, and a little bit further away from the structure to see if there's any differences. And what we found is that we didn't find critical negative effects on the water quality. And for ecology, as you can also see in the moving images, we have seen quite often an ecological enrichment of the system. So we see new ecological systems emerging under the floating platforms. And of course, that's very interesting because it means that floating structures can also become an opportunity for floating and ecological development. And of course, when the projects get bigger, it still remains very important to keep on monitoring these impacts and to keep on doing research on floating structures and ecology. And then governance. So it's not only about technology, it's not only about environment, but also about governance. We need to think about legislation. We need to think about the social acceptance of policymakers, but also of citizens. And these are all very important topics as well. One of the things in international policy, I think that floating developments can contribute to the Sustainable Development Goals of the United Nations. Many different goals, I think, but in particular also sustainable cities and communities, number 11, and life below the water, because we can strengthen the ecosystems under the water. And of course, this is very important. But I think that floating development can also contribute to many of the other topics and goals that you see on this slide. last year, floating urban development was for the first time mentioned in the IPCC report, and the floating pavilion Rotterdam was mentioned as an example of transformative adaptation. So of course we were very happy about that our project was mentioned by the IPCC. And of course we expect that this will lead to more application of floating in international policy, both national policies, but also regional and local policies. Since 2019, floating is recognized by UN Habitat. There were 2 high-level roundtables, one last year, one in 2019, where also by the United Nations, floating was acknowledged as an adaptation option for climate resilience. We see this stepping up for implementation, Busan in South Korea, Singapore, but also in the Maldives. It's now happening, the floating cities. And we were quite happy that I was appointed by the city. Sorry? Was there a question? Or? No?
No,
Okay.
no, it's okay.
And I continue. So we were quite happy to be appointed by the city of Busan to help with the first sustainable floating city prototype and to bring in our knowledge and expertise and help building a sustainable floating city in South Korea. We worked also for the European Commission on a 3-year Horizon 2020 research project, where Blue 21 and Delta Sync, our companies, were work practice leader for living at sea. And here we really looked also at the social acceptance. So the social acceptance from a policymaker's perspective, the investor's perspective, and the end user's perspective. We evaluated different standards and requirements, also building codes, and tried to bring them together in a design exploration. Of course, what's interesting here is that we have to deal with building codes on the land, for instance, the Euro codes, but also the offshore codes, such as the international maritime law and the standards that are applied by the maritime industry. And we try to combine them in this project. So the land-based construction and the maritime construction. We review many different documents, policy documents. In the Netherlands, we already have many policy documents, but also internationally, we see slowly getting more of these standards. And we translated that into the conceptualization and design for living at sea, where we looked at green space, water access, but also the density and other different sizes. In this case, we looked at 45-meter square platforms. And then we translated that in one of our designs that I've showed you already before, very large-scale floating designs. In this case, this design was made for the Mediterranean area in Southern Europe. Here's some more of the building regulatory presentations and publications that we reviewed. All of that was captured in the report for Space at Sea. That's also open access available if you're interested to learn more about this. We have a think tank to talk about governance and regulations. And of course, there's still legal issues to be investigated. So how floating cities are defined legally, which laws and regulations are relevant to investigate, what are the legal consequences, and what's the right legal status for floating cities. And one of my colleagues in our team, Vicky Lim, has co-written very interesting publications about this topic that you can also visit on our website, about the legal framework for sustainable floating city development and legal issues for floating islands. So yeah, we've done some really interesting work on this, and that if you're interested in this topic, I encourage you to also look into this. And then of course the social acceptance, we also looked at that in Space at Sea. Of course, concerns are always the costs and environmental consequences, blocking the view over the water. With regard to cost, I've shown you that in deeper waters, it can actually be cheaper than land reclamation. And of course, we also have to take into account that land is very expensive, but the water is still cheap. So in many cases, I think floating urban development can be competitive if you're looking at costs. But of course, it's still very important to reach out to communities, to explain about these technologies, and also to involve communities from the start when you're developing a floating project. And also in Indonesia, already there was a publication by Jonathan Lekkerkerk and Floris Bogaert already about the social acceptance of floating development. So Dr. Bogaert already looked into this topic together with also Indonesian experts. So I think you can look up his publication about that topic as well. So how do we move forward? How can we look at transformative capacity? I think that floating cities is not only technology, it's also a testing space for new societal models. And so I think in the current society, we often still see the environment as an infinite resource. And of course, we need to move to acknowledging the intrinsic value of nature and to look more at ecological services. And the current infrastructure paradigm is still very much focused on cost efficiency. And I think we need to have a better understanding of the total positive system impact. Our economic theory often still based on internal economic growth, whereas I think we need to have an economy that supports the needs of people and also the needs of the environment. Moving from a very individualistic approach to a more balanced society, from competition to collaboration. And citizens are not only a passive consumer, but they can also produce their own energy underwater in floating structures. Not only centralized government control, but also communities producing their own food and energy, and to move from fragmentation to more integration. So how can we move and integrate water management and flood control with urban planning, with landscape architecture? And well, that requires collaboration of public authorities, the industry, the academia, and citizens. So we need to work together in a quadruple helix model. And we need to move from human beings at the top of the food chains in the pyramid to the left. And how can we be part of the ecosystem again as human beings? And I think floating cities can be a testing space to try this, to see how we can develop different types of constellations, different types of societal models with different values. To achieve that, it's very important to collaborate and to share the knowledge. So we have made all the presentations of the second World Conference on Floating Solutions in Rotterdam. We made them available online, so you can look at them. We also built the world's largest open source knowledge base on floating urban development, where you can look at all the reports and publications and interviews that we did. Also the Space at Sea project, all the reports are available. And we're also a key contributor to the Global Center on Adaptation, also based in Rotterdam in a floating office. And they have a community of practice on floating development, and you can also become a member of that if you want to learn about this technology. And there are many online courses and events and webinars that you can join to learn more about this and the many aspects that I've shown to you today. But there's much more to tell about that, of course, than I can tell you in only 45 minutes. Also, the next World Conference of Floating Solutions is coming to Asia, to Tokyo in Japan in August. Will become a very interesting program with researchers, people from policymakers, also people from companies coming together to discuss floating solutions. Next year it will be in Europe again, in France. So yeah, we see the floating solutions traveling all over the world to work together, to collaborate, and to share knowledge. Our business objective as a company, we want to achieve the proof of skill that requires investments, construction capacity, but also the technical and societal challenges that I talked about. And it's all about collaboration. So here are some of our most appreciated partners to achieve the proof of skill. A very interesting example is this project in Finland, Estonia, where there's a very large tunnel being developed, and along the trajectory of this tunnel, there will be floating islands. Part of these floating islands will be developed by Blue 21 with our partners, Angry Birds and entrepreneurs, Peter Vestabacka, and we have a joint venture with him to develop this project. So this, I think, will be one of the largest floating projects ever made if we're successful in achieving this. And then our partnership with the Shimizu Corporation. So it's already for more than 4 years, we work together with this big company from Japan. And our shared mission is to create sustainable future cities by building underwater and starting with coastal urban expansion, and to do it in a very innovative and ecological way. And of course, it all begins with a dream. So our dream is to make the world more comfortable, secure, and sustainable. That's Shimizu Corporation. And from Blue 21, that's to provide safe, climate-proof urban growth with a positive impact on the environment. So we see a big overlap between the vision of the Shimizu Corporation, the Green Float projects that you see on the right top, and the Blue Revolution vision of Blue 21 that you see on the right bottom. And we're very happy to work together with Shimizu. We have a lot of R&D in our company. I already talked about Hydromec Plus, but also modular platforms with utilities integrated. We're working on multi-use floating islands. And of course, the ecological impact together with Indaimo and the Rotterdam University. We've done a lot of work on that. Because the research remains very important. I think if you look at the transition pathway, we need to move from adaptation to transformation. So how can we move from slow and small pilots to fast, large-scale implementation? And to move towards inclusive transdisciplinary planning with local communities and experts. And to move from reinventing the wheel to mobilizing real expertise and global knowledge distribution. And to address the stakeholder receptivity by creating awareness, association with technologies, acquisition of skills and knowledge, and also to have the right incentives to apply these kind of new technologies. Which brings me to my final part of my lecture, the conclusions. And I want to share with you 3 key lessons that I think are necessary to create a floating future. And the first lesson is that we need to have a big vision, because the challenges that we're facing are very big. And we might have 500 million climate refugees because of sea level rise. So we need to think in big solutions. And we need to move from the demo applications, such as the floating pavilion, really nice project, but we need to move to mainstream large applications. And also to move from inland projects in protected waters to more the maritime applications, such as what we investigated in the Space at Sea research program. And how can we build a significant part of the houses of 3 billion people in 30 years? We can only do that by involving investors, big companies, but also work on policy acceptance. And secondly, I think we need to keep on monitoring learning and global knowledge distribution. So with the drones, we need to do research on the impacts, work together with universities, but also we need to work on international capacity building and global knowledge distribution, such as with the GCA. What we're doing with Blue 21, we make our knowledge available, open access for everyone, so you can read the reports, you can also learn about this technology. And I think that's very important because we cannot do it on our own, we need to work together. And that requires also connecting, the third point. We need to connect technology with the socioeconomy and the ecology. But we also need to connect research with business, with government, and with communities. And all of that, I think, will lead to a new field of expertise. So I'm a civil engineer, but I think in the future we will see a new expert, and those are called the maritime urbanists. So these are people that combine urban planning, architecture with maritime engineering. We're building this new expertise in our team. I think this expertise field will be very important to develop the floating housing and the floating communities of the future. And then the final conclusions, my final slide is that I think floating structures are an important proven technology to tackle global land shortage in a climate resilient way. Floating structures are not the only option, but I think they should be included in the strategies of cities worldwide when they are developing strategies for urban development. Our research shows that ecological impacts can be positive, and this could be even more so when applying ecological design principles above and underwater. Floating urban development can also be an ideal development environment for regeneration and economic innovation. Knowledge sharing, international collaboration, R&D, and creating real projects for scaling up floating developments remains key. And I think, this brings me to my final point, and that's the Q&A. So if there's any questions,
Yes.
I would welcome them to have the questions.
Yes.
Thank you very much.
Thank you very much. That was very interesting presentation, Dr. Roger. And I've been in Rotterdam on last January. So
Excellent. Yeah.
yeah, for five time for me visit Rotterdam, and
Oh,
also
very good.
on 21 January 2023, I also visit RDM campus. So I know where the floating building there. Okay, and the second one, I'm so proud that you show my paper on your presentation. You know that social acceptance for floating house is,
Excellent. Yes.
yes, my paper. I'm as a first author in that paper.
Oh,
Okay.
very good. Well, that's
Yes.
excellent. Yeah, I think it's a very good paper, and I think it's a very unique one because it's probably one of the first times that people have studied the social acceptance in this way. And
Yes.
yeah, so that was the reason why I wanted to show it, of course. And I know that Floris Bogaert, who's a very close colleague, he worked on this together
Yeah,
with you
together
and your
with
colleagues. So,
Floris
yeah,
Bogart. With Floris Bogart,
yeah,
we have
yeah.
more than 2-3 paper collaboration from Unisula Semarang with Rotterdam University of Applied Science and also Hans University with Floris
Yeah.
Bogart. Yeah, okay. And ladies and gentlemen, the participant, now let's continue to the session question and answer. Please, before you ask a question or give a comment, please raise your hand, mention your name and your institution. Please. Any question? Oh, let's see the chat room. I will see the chat room. Okay. Which one? I cannot find the question because only thank you, thank you. Yeah. Yes. Can you help me to read the chat because I cannot find in the chat room of my Zoom.
Okay, I will be write the question of the first question is from Jasper and group 1. Typhoon Haiyan was the worst typhoon that hit the Philippines. It had an estimated sustained wind of up to 315 kph and persistent tsunami with the height of up to 6 meters. In this kind of area, which are frequently visited by strong typhoons, strong winds, and high tsunamis. All year around, are floating structure sustainable and flexible? Also, what is the maximum load per square meter for floating structure based on your design?
Okay. Yes.
And I think that's an excellent question, of course. And I think, of course, as a civil engineer, everything that we make needs to be safe. So that's our first concern. And of course, there's no civil engineer or maritime engineer that wants to be responsible for a project that fails. I do think with storms and natural disasters and typhoons and floods, I do think that more and more we experience that the cities on the land are not safe. And because we face a lot of flood damage, as the example you mentioned. And what happened in Pakistan, also in the Philippines, what happened 70 years ago in the Netherlands, big part of our country was flooded. So I think that the cities on the land are not safe to flooding often. And the floating projects, they can be safe if they're engineered properly. With regard to tsunamis, we have done a lot of research on this, and you can verify those publications yourself. And what we find, and I think also that has been demonstrated in real tsunamis, is that a tsunami is a very interesting phenomenon, but what we see is that the height of the tsunami only builds up when it approaches the coast. And so in the middle of the sea, the tsunami it's a very long wave, but not such a high wave. So what we see is if we locate floating projects in waters that are not too shallow, which we need to do anyhow because we need depth. So if you put a floating structure in waters of, let's say, 10, 15, 20 meters, we see that the tsunami passes under the floating city or the floating project, and only when it approaches the coast, it will build up. And by functioning like this, the floating project can become a flood shelter for the people on the land. And so if you put the floating projects on a proper location, the tsunami can just pass under it, because the wavelength is very long in relation to the size of the floating project. And only when it approaches the coast, this very big height of the tsunami will build up. And we want to go one step further with this in our design. And we also are investigating possibilities if floating projects could mitigate tsunamis. And so could floating projects take out part of the tsunami energy to also protect the coast? And this is what we're evaluating also with the TU Delft. And then with Typhoon, we had one student, Kelvin Coe, and he evaluated the technical feasibility of making high-rise floating structures in typhoon conditions, in very high wind load. His research showed that this is possible. Of course, it requires quite heavy and large floating platforms. You need to engineer for this. So in your question, what kind of loads can my structure withstand? We always start from the other way around. So we start with the loads. So if I'm developing a project, I look at the critical loads, and then that will be my starting point for my design. And so the floating pavilion, you could not put in typhoon conditions because it's designed for Dutch conditions. But if we do a project in Asia, and we will design that project for typhoon conditions, and to make sure that all the projects that we do are safer than the projects on the land. So that's really a core part of the Blue 21 approach, that all the projects that we make are safer than the projects on the land. So they can withstand the winds better, they can withstand the waves better. And by doing so, I think we're creating the social acceptance that floating can become much safer than building on the land. And that was also shown by the example that I showed you with the pavilion. The pavilion was fine, and then parts of Rotterdam were flooded. And I think we need to have these kind of examples all over the world.
Okay, Dr. Roger, we still have 10 minutes left, and you have 1, 2, 3, 4 question more. Okay, from Muhammad Ayat. The question is, does wastewater for the floating project will be directly drained or connected to the city's drainage system?
Yeah, that's a good question. Yes, you can connect it to the city's drainage system. So it's possible to collect the wastewater in the floating projects, and you just install a sewer pump, and the sewer pump pumps it to the city on the land, to the sewer. But that's not our preferred strategy. So what we did in the floating pavilion, we like local wastewater treatment in the floating projects so that we don't need a sewer. And of course, if you build floating projects, you create large cellar space and platform space. And in these platforms, you can integrate wastewater treatment. And then the water that you discharge to the environment can be even cleaner than the environment itself. So you're helping to improve the water quality. And so that's our preferred strategy, to integrate wastewater treatment, but also drinking water production, to integrate it in floating infrastructure and floating buildings, so that also the floating developments can become partly self-supporting. But to answer your question, it's technically very well feasible to connect floating projects to the land with sewer infrastructure, with drinking water infrastructure, with electricity cables. So you can connect everything, and that is possible. But I think there are better technologies available, and to have local solutions.
Yeah. And we move to next question. Would it be more cost effective to operate for floating cities rather than expanding cities on land? Which one is more cost effective?
It depends, of course, on the local situation. So it depends on the value of the land, for instance. Depends on local construction prices, the cost of labor, the cost of construction material. So every situation is different. But in general, of course, if you expand a city on the land, you either take up agricultural land or you take up nature, and you need that. And if you expand on the water, you can sometimes even create new nature. So there's many benefits. Plus, if you expand the city on the land, you increase the flood risk. because often if a city expands on the land, you're moving into river floodplains, you're moving into coastal floodplains, so you increase the flood damage, which will also lead to more costs. So then even in our estimations, we see that floating constructions are often 10% more expensive, but there's also much benefits. Because you reduce flood risk, you keep the nature, you keep the food production on the land. These are all very important topics. You reduce travel distances, so you don't need to create very big highways because people might be able to have an electric boat or to go to their work with on a floating bridge. So I think there's also many cost savings that can be applied when you apply floating structures. So in general, I think it's an interesting strategy for cities to seriously look at.
Okay. And then next question from Paula Bianca. Is there a possibility that floating project will sink in the future? If so, is there any solution for this? And how can we prevent this from happening?
Yeah, so of course, as I said, safety is our main concern, and we need to make projects that will not sink. And for instance, a floating pavilion, it consists of a combination of polystyrene and concrete. And polystyrene is encapsulated air bubbles on a very tiny scale. So the only way to let that building sink is to completely destroy the building. Then it will sink. But it cannot sink because the air is encapsulated in the building material. And of course, if we make concrete foundations, we always make compartments. So then it can destroy one compartment, but the project will still not sink. And of course, if you throw a big bomb on a floating project, it will sink. But that, if you do it on the land, the building is also gone. So the projects that we engineer, they are safe and they're safer than the buildings on the land. And we, in proper engineering and design, you have to make sure that there's always risk management strategies in your design, compartmentation of your platform, using polystyrene so that the water cannot get in. Yeah. And then even the polystyrene will be coated again in concrete or a coating. So there's many safety measures that you always apply if you do it the proper way.
Yeah.
But still, there are examples of sinking floating projects. So if you don't have the proper engineering, you don't think about the balance, about the hydrodynamics, about the waves. We calculate in our software what happens to our building if a wave occurs that only occurs 1 in 10,000 years.
Yeah.
So we do a statistical analysis of a wave, and then we take a very extreme wave that we never have seen, but that might only occur 1 in 10,000 years, and we apply this wave to our building and then see what happens.
Yes, you're right.
And then still it should be safe. And you can say, 1 in 10,000 years, that's very extreme, but okay. The 1 in 10,000 years may become 1 in 5,000 years with the climate change.
Yeah.
We don't know. And be aware that a wave of 1 in 10,000 years means that there are 1% chance that it occurs in the next 100 years.
Yeah.
And then we want to prepare for that. So these are the kind of safety standards that we apply in our design. So we need state-of-the-art, proper maritime engineering to create safe projects. That if the city on the land is completely flooded, that the city on the water is still safe.
Okay. Yes, we still have 2 questions, and it is last question, because we have no time more. Okay. A question from Christopher. Does the floating construction get affected by the substantial increase or decrease in the depth of water due to varying weather condition? If yes, how can it be addressed?
Yeah, that's a good question. So in general, we create floating projects with mooring piles. So if the water goes up, the floating building also goes up. And so the mooring system makes sure that the building doesn't float away. So we don't want to have a building floating away, but we do want to have vertical freedom to go up and down. So if there's a high tide, the building goes up. If there's a low tide, the building goes down. In general, with floating, we're more concerned about low water levels than high water levels. And because if there's a very low water level, we don't want to have the floating building on the ground.
Yeah.
And if the water level is very high, that's no problem because the building just goes up, so that's okay.
Yeah.
So we do a very statistical analysis of very low water levels, for instance, a very low tide in combination with a low river flow.
Yeah.
In case of the floating pavilion, we evaluated a very low river flow and then at the same time a very low tide. And then also at the same time a wind blowing away from the land, so you have a very low water level. And then still you want to have enough water under your platform that your building will not sit on the bottom.
Yeah.
So it's always very important to do location analysis and to look at low water levels, also to take into account sedimentation and to look at future water levels. And water level might be okay today, but if you have sedimentation, the water level might decrease. And those are concerns that we need to take into account when we are creating floating projects.
Okay. And the last question from Pak Abdul Rohim. Refer to your slide presentation, page 13, plotting between the cost and the depth. As for floating development in orange color, what is the depth?
Okay. Yes. Orange.
13. Page 13.
Yes.
Yeah.
Okay. So then maybe I need to go back to my slides, page 13. Let's have a look. Okay. Yes.
Yeah.
Yes. So what is the depth? So in this case, the break-even point, but this was a specific case study that we did for, it was 12 meters. So in 12 meters was the break-even point. So then in that case, the floating was the same price as land reclamation. And this break-even point is different in every location because we need to have a good analysis of the local conditions. But in general, we say that if the water depth is higher than 10 meters, the floating becomes very attractive. Between 5 and 10, it can still be interesting. If it's lower than 5, it can become difficult because the depth might not be enough for the big projects. Could still be good enough for the small projects. And then, of course, if you go into very deep waters, then your mooring piles don't work anymore. So then you need to work with anchors. So that also gives some complications. Still possible, but not always the preferred option. So in general, if you're talking about the water depth between 5 and 20 meters, that's very suitable for floating development.
Okay. Pak Abdul? Okay. Yeah. Still, there is still one question last for participant. I'm so sorry. This is a very, very last from Cindy Matao because the participant is very enthusiastic with your presentation. The last, very last one. Does your team delve deeper on the maximum force that the floating construction can resist to maintain stability?
Absolutely, yeah. So that's always we have our own calculation software, engineering software, and safety is always our main concern. So the very extreme waves, very extreme winds, that's what we take into account. And of course, what's also important is the comfort level. So we want to be safe, of course, but we can be safe, but we also don't want you to be seasick every day. And so we also calculate the accelerations of our buildings and platforms to make sure that it's comfortable to live there and that you don't have too much movement.
Yeah.
Because you could make a project that moves a lot. It could still be safe, but it's not comfortable.
Yeah.
And you become seasick, you cannot work there, you cannot live there. So these are also very important aspects. So safety and comfort are always the number 1 and number 2 objectives for every engineering project that Blue 21 does.
Okay. Yes, we have no time more. So, do you have any sentence or closing speech for your presentation?
Yeah, so thank you very much for inviting me. It was a pleasure to give the presentation, and I think you had excellent questions. So I think it shows that you're very interested and that students are very smart. So that's always good. Yes, and this is an introduction to the topic, but yeah, if you want to learn more, I invite you to go to our website, to the resources page, where you can find much more about this topic. If you want to learn more about it, and you're very welcome to do that. And yeah, apart from that, I wish you all the best with the continuing of your study.
Yes.
And I hope you will have a very good and positive impact in your career. Because yeah, there's many challenges, and we need the young people and the students. We need them to address these challenges. So I wish you all the best, and good luck with your studies and your career. And thank you very much for your attention.
Okay. Thank you very much, Dr. Roger. And also, we can join in a World Conference on Floating Conference. Is it right? 2023.
Yes, so
Yes.
in August in Tokyo, there's the World
Tokyo.
Conference on Floating Solutions.
Yeah.
I will also be there, and many experts from around the world. So it might be a good opportunity. Yes.
Okay. Yes, thank you very much for Dr. Roger for your
Thank you.
time and your interesting presentation. And also thank you very much for all participants for joining in this session. And okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much for Dr. Roger de Graaf and moderator Dr. Henny for amazing presentation. Today, we already discussed about many things, especially about the polder system and the community who manage the polder. And the second session of the day, we learned about the compact soil and about floating construction. All of that, we would like to say thank you very much to all the speakers with amazing presentation and knowledge, and the participants also, who always give attention to our agenda today.
As master of ceremony, here I am. For our deepest heart, we do apologize for our mistakes in presenting our agenda today. Before we do closing, don't forget, I will remember all of the participants to do into present form that has delivered by some committee and the bodies one. And then before we closing, we'll you and then remembering. See you on next meeting of third day RMI week 20 and 24 tomorrow. Before closing, I will invite all of the participants to opening your camera, because this session is we have a photo sessions.
Please turn on
Please
your
turn on.
camera.
Yeah, all of your camera.
Okay, the slide 2. Turn on the camera, please, participants. Okay. Slide 2 dulu. Okay, slide 3.
For the last ones. Okay, it's already the time is enough for today. We will see you in next morning, in next meeting, I'm sorry, for the third day RMI week 20 and 23 tomorrow at 9 a.m. Jakarta time. See you on the next morning. Assalamualaikum warahmatullahi wabarakatuh.